So we looked at pure substances and saw that the composition does not vary in pure substances. So pure substances were elements and compounds. Now we're going to be looking at when we combine elements and compounds, we make a mixture. And there's two types of mixtures we're going to talk about, homogeneous and heterogeneous. So here in this box, you can see we have some atoms, we have some compounds, we have some molecules. So mixtures are a combination of all of those. Okay, so here's an example of homogeneous with the vinegar and heterogeneous with our salad. First, we're going to look at homogeneous. So the big thing here is that the composition does vary sample to sample. Okay, so with the pure substance, it doesn't, but with a mixture, it does. So, for example, if you are a coffee drinker and you make coffee every morning, I don't know what you put in it, but I like to put a little creamer in it every morning, but I don't measure that out, right? I just kind of take the bottle and I pour it into my coffee cup, and I stop when the color looks right, So the way I made my coffee this morning may be different than the way I made my coffee yesterday. So the composition is varying from sample to sample. So that's different than what we saw with the pure substance. So first up, homogeneous mixture. We see a single phase, okay? We also call homogeneous mixtures solutions. So you may want to circle or highlight that, solutions there, okay? So it has constant composition throughout the material. So vinegar here is an example of our homogeneous mixture, but you can't see the two different things, right? You can't see water and vinegar separate because they're mixed together. So that's what it means by one phase. The components are indistinguishable. And then they can be separated by physical means. We're going to look at that here a little bit more in just a second. Now, heterogeneous mixtures have two or more distinct regions. So in the salad, that went away here. Let me see if I can go back. Nope. Okay, in the salad, we can see, what is in there. We can see some avocado, we can see some strawberries, some pecans, some spinach, some blue cheese crumble. It even looks like there's some bacon in there, some peas. Okay, there's all kinds of things in the salad, and I can see the different components. With a homogeneous mixture, I can't see the different components, but with heterogeneous, I can. So you kind of have to be careful, because, if you have orange juice that you're drinking and it has pulp, that would be considered heterogeneous, because you can see the little bits of pulp in the juice, you know what I mean? So if you can see different components, then it is heterogeneous. And it can be separated a lot easier than a homogeneous mixture. So especially with the salad, right? We can just pick apart the components. So we can put strawberries in a pile, spinach in a pile, you know what I mean? It's very easy. It's a lot easier to separate than a homogeneous would be. Okay, so here's some separating separating the mixtures, the different means of separation. So the ones I like to talk about are go down to boiling point. So distillation is something we would use for a homogeneous mixture. So let's say we have a saltwater solution. Okay, so to separate the water and the salt, all we would have to do is set up a distillation, which is basically we would boil the water. The water would evaporate, and we could, catch that and then condense it back down to water. But the salt is not going to evaporate. So once we boil out all the water, the salt will be left in the beaker. So again, we can separate a homogeneous mixture. It just takes a little bit more work. Then let's look at the one right below it, state of matter using filtration. So if I have a mixture that has, a solid and a liquid, And that's very easy to separate. All I need is a funnel and some filter paper. I pour the mixture into the filter paper. The solid stays in that filter paper, but then the liquid runs down into, through the funnel into the beaker. So that's a very easy way to separate a solid from a liquid. And there's other forms there: chromatography, evaporation, magnets, filtration again. So there's other ways to separate mixtures, but those are the two I really wanted to point out to you. Okay, so let's see if we can classify the following here. So air is kind of tough. A lot of times people think air is a pure substance, but it's not. Air is made up of several different gases. And anytime you have a mixture of gases, it's always homogeneous. Okay, so air is going to be homogeneous. And again, it's just because the gas molecules are very spread out. So it makes it easier for them to mix because they're so spread out. Okay, chicken noodle soup would be heterogeneous, right? Because we can see what's in the chicken noodle soup. We can see noodles, we can see chicken, we can see broth, carrots and celery. So we can see the different components. Okay, then iron. Iron is on the periodic table. It is a pure substance. It's an element. And then lemonade, that one's kind of tough because it depends on if you have pulp in your lemonade or not. If there's no pulp and there's only one phase, okay, then it would be considered homogeneous. But if you had pulp in your lemonade, then we would say it was heterogeneous. So that one's a little tricky.